Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of proportional and non-proportional graphs. This is standard 8.5F in the great state of Texas, and we are using item number 2 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've just got 4 graphs, and we need to find the graph that has a proportional relationship. Now, here's the problem. On the 8th grade STAAR test, you are not going to find that definition anywhere on your mathematics chart. So you need to go into the test understanding what that means. So we will talk about what proportional means, but there's also kind of a trick to being able to solve this problem if you totally forget what that means. But let's review what that means. Proportional. All right, so we've got proportional relationships. And so that means, by definition, the other ones are going to be non-proportional. And really in 8th grade, we are looking at 2 different types of equations that are very similar, but have a slight difference. So the first one we're going to look at is what we call direct variation. So this direct variation is y equals kx. And it's proportional because you're looking at the relationship between x and y. And the only thing that is different is you're multiplying this x by this k, whatever that k is. Could be a whole number, could be a decimal. And that is changing what happens to y. But it's proportional because if you wanted to, right, you could turn it into a proportion, and you can actually solve these problems as proportions. And they form a proportional relationship and all that stuff that we did back in 7th grade. So non-proportional looks like this, and we usually just call this the slope-intercept form, but it's y equals mx plus b. And the only difference here is this plus b. So if you take that out, you've got y equals kx on proportional, you got y equals mx on non-proportional. The k and the m, they both represent the same thing. It's the slope. It's what you're multiplying by x to get to y. But the non-proportional has this little extra waggle back here at the end, plus b, and it's the y-intercept. And so what that means is that you can't put it into a proportion. It's not exactly proportional because you've got this plus b, and sometimes it's plus, sometimes it's minus, changing how that equation rolls out. And so if you took that y-intercept out, well, then you would have a proportional relationship. And so what happens if you make x 0, right? So if x equals 0, well, in my proportional relationship, y would equal 0. In my non-proportional relationship, y would equal b, right? Because if your x is 0, then you're just kind of getting rid of the mx or the kx. And so that's the difference. So if x is 0 and y is 0, you know what that means? On proportional relationships, which is what we're looking for, it means it goes through the origin. That's the trick here. Proportional relationships always go through the origin. And take a look at f. F goes through the origin right there. G has a y-intercept of 2, so that's the slope-intercept form. H has a y-intercept of -3. And J has a y-intercept of -2. It's just a straight line all the way across. So if you are stuck, you have no idea what proportional relationship means, try to find the one that's not like the others. And if you notice, there's only one of these graphs that goes through the origin. The other 3 skip it, which means these other 3 are slope-intercept form. Our answer here is F.